design where a route that's learned from, a route that's learned from a VPN site, let's say like BB1, and it's sent in down to another VPN site that has a backdoor link, we may want to have a situation where we do not accept. So we do not accept routes on R3 if they came across that backdoor link. So what we want to do is we want to drop those routes that come across the backdoor link. The way we're going to do it is we're going to use something called a site of origin attribute. So we're going to use the site of origin attribute. So what we're going to do is on R6 and R3, we're going to set what's called a site map under the interface, and then it's going to route a map. It's going to reference a route map, and that route map is going to match match the site of origin attribute. So what we're going to do is we're going to ensure that if we see an EIGRP route that comes in with a site of origin attribute that matches what we have configured on the interface, we're going to drop that route. So commonly, the configuration would be under on the PE routers. On the PE routers, R6 is going to have a receive map, not a receive map, but a site map on that interface to the CE. R3 will have a site map to that interface to the CE, which is R7. But also, these routers here will have a site map for their backdoor link. So what we'll have is, we'll have, let's say, R8, it'll tag it with a site of, maybe 10.8. And then what we do over here is, on our site map, on R3's interface, we say deny essentially match this. And if anything matches this, it gets dropped. So you're going to drop it there. And over here, you may do like 10. What happened there? So over here, you may do, like 10.7. And then, of course, you're going to match it down here, 10.7. Now, in this little network and the little design you see here, it really doesn't make a lot of sense for this. It may not be 100% clear why you would do this, but in a large scale, EIGRP network for your customer, you're not going to want the possibility of a route going into a VPN site and coming back out of that VPN site right back to you. Okay, it's not going to create a routing loop, but what it does is it creates convergence problems. It creates problems with the routing tables converge, that route looping around. All right. All routers in the EIGRP domain must support this feature. They must support this site of origin feature because you'll see that even the CE routers are doing it. In our case, we're doing two 3550s here, actually 3560s here, but they don't support the site map option. We can't configure this on here. The likelihood of getting something like this in a CCIE lab, I would say would be pretty slim. Why would I say it's pretty slim? Because it burns up a lot of routers. You've got to have a lot of routers configured with EIGRP. If you look at it, what we have here, just between, if you look at just this half of the network here, that's 5 routers. We got 9 routers in the lab. We're burning up 5 of them just for this one design. Not very likely. Likelihood of seeing this in the real world? Not very likely. Does the network still work when you don't have EIGRP site of origin configured? Yes. Okay, it just may take a little bit longer to converge. But the basic idea is that we're going to stop the routes. We're going to stop the routes from getting fed back in that loop, that possible loop that can occur. And it depends a lot of the timing. How long did it take the update to go from 6 to 3? How long did it take the update to go from 6, 8, 7, and then the 3? It depends a lot of that timing to determine if we're going to have a problem or not. All right, but the configuration we're going to use, and I'll show you what the configuration looks like on the whiteboard here, because I said like the switches don't support this config here. So what we're going to do is we're going to match it here. So we're going to set the EIGRP routes. So like these EIGRP routes here that come across this backdoor link here do not get accepted by R6. So R6 will not accept these. These EIGRP routes that are set across this backdoor link from R8 do not get accepted by R3. So what you're saying is I want to purely accept the MPLS VPN. Okay, so I want to accept this MPLS VPN. That's the only ones I want to accept. All right, it's not a very common solution. You'll find one example on CCO about it. But basically, basically the idea is to enable the routing tables to converge faster. The basic logic behind it. And so, as like I said, speeds up routing convergence when backdoor links are used. So like I said, prevents EIGRP routes from being learned from one VPN site P onto another VPN site, and then finally back to the same PE. The feature must be supported by all routers. So, and this is not relatively new, but it'll be supported in all the routers you use here. All right, so the configuration, like I said, this is what we have. You have this inbound on the PE's links to the CEs, and then you have this also on the backdoor links that the CEs have. So you're going to do an IPVRF sitemap, and then a set extended community. So set extended community, site of origin, and then there's the value. So if you receive any updates in this interface that have that value set, what you have here, you're not going to accept these routes. So like in this case, if this was R3, we would go on to R8's link, backdoor link over towards R7, which was FA 0/15, and then we would apply this right here so that we can set for those EIGRP routes. So we can set this site of origin attribute for these EIGRP routes. All right, not a very common config. If I was rating it, if I was rating this on 1 to 10, I'd give it a 2, maybe a 1 even. It's just not very common. Okay, but the hard thing to get through when you first see it, like if you see it in a book or something like that, a lot of them is really gray. It's really gray in how it's kind of like a gray area. It's like their explanations just really aren't clear exactly what's happening or what's configured where or so forth there. All right. Now BGP site of origin, that's going to be a lot more common. Not too, not like on a scale of 1 to 10, it'll be like a 5 or 6. All right. But so the basic idea is just to reduce, I should say, the time it takes to converge your routing tables because of that looping around. Seems like a lot to do just for that one issue. But I imagine, somebody come up with this really good idea, and, they put in this feature here. Okay. So we're not going to do an example of this because, like I said, first of all, it's just not very common, and second of all, the switches don't support it there. But basically, like I said, what you would do is you would R7 would set it across the backdoor link. 6 would also have it on its inbound interface, so it drops the ones from 7. 8 would have it on its outbound backdoor link, and then 3 would also match that, and of course drop it there. And there's never actually, I should say, there's never actually any matches that go on. It's always you're doing a set on it there. So you're going to set that community there. If that's what you're setting, you will not accept EIGRP routes with that in. It's it's a very convoluted feature, I would say. I mean, the way it's implemented, it looks like it's something for BGP. I mean, this the way it looks. It doesn't look like something for EIGRP. Seems like they could have made a a command for EIGRP for it, just to make it a little bit more clear. All right. No, someone asked a question. Is there no match community and deny? No, it's set. If you have it set on that interface and you receive an update with your same site of origin, the update gets dropped. So there's no match, deny, that kind of logic, and that's why I said the logic of the commands are really confusing. Okay. So let's go here and let's go on now and let's look at OSPF as a PE to CE routing protocol. All right. So when we're going to run OSPF, we're going to see, we talked like EIGRP. When we talked about EIGRP and the site of origin, sorry, not the site of origin, we talked about EIGRP and the autonomous system ID. OSPF is going to take it one step further. So it's going to take it one step further. So we're going to have, within OSPF, we're going to have a little more complexity here. In OSPF, we're going to actually lab up here. Okay. And so let's look at the high points real quick here. So when running OSPF, as PEC implements, we're going to have to do redistribution, pretty much standard. We do not preserve the route information here. We do not preserve the route information unless we configure it a certain, unless we configure it to preserve this route information. Okay. So what we can do is we can preserve the originating area, the LSA type, and also is it external one or is it an NSSA route there? All right, so this is the information that we'd be able to preserve here. Also, it maintains the router ID there, so we don't have duplicate router IDs within the network. Not to say we don't duplicate router IDs, but we want to know the router IDs. All right, and it also defines a new attribute, a new field called a domain ID. Okay, we don't see this in the RNS CCA lab for OSPF, but we're going to see it here, there. Okay. So the domain ID tells the route, essentially it's telling the other routers where the route was originated from. That's the basic, the whole idea behind the domain ID. So when the domain ID matches on a VPN site, MPLS network is treated like OSPF area 0. Okay, the MPLS VPN, which is called the super backbone, for lack of a better term, I guess, it's treated like an area 0. So OSPF routes from VPN site 1 will be seen as inter-area on VPN site 2. So the routes will show up as inter-area. So if I have routes learned across my MPLS VPN, if they're intra-area, when they go across the MPLS VPN, they will become inter-area. Right. If the domain ID is different, so if the domain IDs do not match between the between the PE routers. All the routes show up as external. So your inter and intra-area routes that you're passing in to IBG to multi-protocol IBGP and sent across the implicit VPN will now show up as external on the other side. By default, your domain ID is based upon your process ID. If your process IDs are not the same, you can specify the domain ID under the routing process. So the situations that we run into, the common situation is our domain IDs match because our process IDs match. Routes learned across the implicit VPN show up as inter-area because the implicit VPN is treated as area 0, as a super backbone. And if the process IDs don't match, which in turn means the domain IDs don't match, they will come across as external. You really want to pay attention to how these routes go across. What are the ways you can make it show up as an internal OSPF route or an external OSPF route? We'll actually look at how we can make routes show up and remain as intra-area routes too. Okay, so if the process IDs match, between the routers here, what we're going to have is the routes will show up as inter-area. So the routes will show up as inter-area here. Let's go ahead and apply this configuration here. Share this out real quick. Okay, everybody should be able to see my screen here. All right, now this is the best part of the EIGRP configuration. No router EIGRP 100. My favorite part. Move it real quick. And remove it over here. Okay, so EIGRP has been removed. Now we're going to switch this over. We're going to switch this over to OSPF. Let's do area 0 here. So we'll do area 0 between the CE and PE routers. We won't worry about the backdoor link for now. Save ourselves some headache here. We'll just bring it down. Doesn't necessarily save us a headache. It just lets us do. Let's just go ahead and pre-configure it, and then we'll bring it up later. So router OSPF. Let's just do 100 here. We're going to also have to have 100 on R6, 100 on R3, and we'll do 100 on R7 there. All right, router ID. I highly recommend you set those router IDs. Definitely a good idea to set those router IDs there. All right, network 10.0.0.0. And let's put everything in area 0 here. And we will also just do redistribute. This is bringing that other loop back in. Redistribute connected subnets. I don't normally like to do redistribution without a route map, but just in this case here, I don't like to do something, but in this case here, because it's only the one interface and to save time, we're not going to create a route map here. When we redistribute anything into OSPF, we don't need to specify a metric. It always comes in as E2 with a metric of 20. Okay, so now let's go to 6. Router OSPF 100 VRFB, and let's specify my router ID, and I'm going to specify the router ID for the interface. And then you can run into little problems if you try to configure OSPF before you have an interface in the VRF, because it's going to complain that it can't allocate a router ID there. All right, let's get the first two up real quick. Get this up. Okay, so it's already up here. And what we're doing, if you look at your diagram, we're switching the protocol from EIGRP. We're switching the protocol from EIGRP between R6 and R8, and between R3 and R7, just over to OSPF area 0. There is no backdoor link between the two. So the only link between the two now will be the MPLS VPN. So we're just switching the PE to CE routing protocol. That's all we're doing. Later on, we'll bring up the backdoor link just for fun. No, it's not just for fun. Just to create some additional issues that we'd like to see. Okay, so that's up. Show IP route VRFB. I have the loopback in there. I have that as external. That was redistributed in. And I have the first loopback. This is the second loopback, and this is the first loopback. Okay, let me go back to 3 real quick. Router OSPF 100 VRFB. And router ID 10.1.37.3. Network 10.0.0.0, 0.255, 255, area 0. Okay, and let's go to 7. Router OSPF 100. And router ID 10.1.7.7. And network 10.0.0.0, 0.255, 255, 255. Area 0. I personally, when I'm in the CCI lab and you know I'm on there configuring something, I personally like to do a lot of my config in Notepad. You know, like just the I'll do the if I'm configuring, like a good example like OSPF, I'll do the PE routers config, then I'll do the CE routers config, which are pretty identical for the PE routers. Then I'll just go and then dump them in the routers. I personally like to do it there. I like to see it. For some reason or another, seeing myself type in a Notepad lets me catch any sort of small mistake. All right. Sometimes I like to pull my configs out also too and look at them in Notepad just so that I can see, what exactly is going on without looking at the screen, the router screen there. Okay. Let's go 3. Show IP route VRFB. Okay, so we have that route there. Let's go ahead and do the redistribution now. Bring in that loopback. So we don't have the routes across the MPLS VPN yet because we haven't done any redistribution yet. So router OSPF 100 and redistribute connected subnets. Okay. One thing you may want to get out of the habit of doing is always using the same process ID. So it's always using the same process ID over and over, or the same autonomous systems when you practice. It's really good to scramble that stuff up. You know, to switch over. Now I'm going to do, you know, when I do this lab, I'm going to use OSPF 200. When I do this lab, I'm going to use OSPF 51. You know, whatever process ID there. All right. R6 shouldn't have any routes to send because R3 shouldn't have any routes to send because it's only got that directly connected interface. There's nothing else in the VRF. You could go on to, you know, you could make a new loopback if you wanted, and IP VRF 14B, IP address 10.1.6.6. Then we should see if he learns the routes. That interface should get picked up by the OSPF network statement. There it goes. So now it's learned. Not too many examples you see loopbacks that are in a VRF, but you can do it. And you can put a loopback in a VRF for, you know, all kinds of reasons. You can also put a tunnel in a VRF too, GRE tunnel. It's a little bit different. It's not, you don't say IP VRF forwarding, you say tunnel VRF and then the VRF under the GRE tunnel there. Okay. Just added that there. All right, so now what we can do is go ahead and do our redistribution. The router OSPF 100 VRF B redistribute BGP 200 subnets router address family IPv4 VRF B. Now, when we redistribute OSPF here, so when we redistribute OSPF, we don't actually have to put the VRF in here. You can if you want here, but what we want to say, match internal, external, external 2. We want to get all the routes. By default, those externals will not go. So by default, when we redistribute OSPF into BGP, the externals will not go in. And let's actually do that then. Let's just take a default redistribution. So what we're going to do is we're just going to redistribute OSPF 100. You can also say VRF, and then specify your VRF there if you want. And let's go to 6. We could actually take this one step at a time, meaning that we could go and look at the routes learned across the MPLS VPN, show IP, BGP, VPN, all, summary. So I got 3 routes learned across. Let me look at what they are. So I've got 6's loopback. I have R7's loopback, and I have the link between R6 and R7. Sorry, R3 and R7 there. I think I created that. Sorry, that's not R6's loopback. Let me step back. That's the loopback I added actually on R3. Sometimes talking and typing, it's easy to switch IP addresses around. Go back to 3 real quick, but let's look at its routing table. Do we see here the external did not go in? See it? So there's the external route, but it's not learned across the MPLS VPN. The reason it's not learned across the MPLS VPN is because of the fact that we're not redistribute there. So let's look real quick. Show run, begin router OSPF. So there's what we have here. This is R7. So this is R7 here. So what we have here is just a router ID, redistribute connected subnets, and then the network statement. Pretty basic, pretty straightforward. We redistribute connected because we wanted to see the external route. Now let's go over to 3, show run, begin router OSPF V, 100V, I should say. So what we have here, this is the OSPF process for the VRF. We have a router ID set, default log neighbor changes there. We have the network statement. We put all interfaces in the 10 network in area 0. We are redistributing BGP in, and let's go down to the BGP config for this here. So address family IPv4 VRFB, redistribute OSPF 100 VRFB. When we redistribute OSPF into BGP, the externals do not go in by default. The externals do not go in by default. We're going to want to bring those in. We need to tell the router to bring those in. So let's go back and add that back in. Because when we looked at R6, just one more time real quick, we saw the routes were not there. The routes for the external OSPF ones, and that's the 7.7.7.7 loopback, that's on R7, is not there. So let's go to 3 and let's bring that in. Router BGP 200. And add internal, external 1, external 2. So now I'm going to bring them in. I'm going to remove that EIGRP statement there. All right. Let's see what we have here. Still has that redistribute EIGRP on there. I'm not going to worry about it. It's left over from earlier. But now I have that's internal, external 1, external 2. So I'm bringing those into multi-protocol BGP. Let me go up to 6. And now I can see I was able to bring across that route that was external there. All right. Now we're going to do the same thing on 6. We're going to do the redistribution. The only problem that people run into with this config, like I mentioned, is they forget or they're not aware of the fact that redistributing OSPF into BGP, externals do not go in. You need to specify you want those externals. By default, only internals will go in. So router OSPF 100 VRFB, redistribute BGP 200 subnets. So router BGP 200, address family IPv4 VRFB, redistribute OSPF 100. You can put the VRF here if you want, VRFB, but we're already under that VRF config, so it knows what OSPF process we're talking about here. And match internal, external 1, external 2. All right, now we should go to the other C router here, which is R8. This is what we have here. So we have the routes learned across, but you'll see they are all inter-area routes. So these routes are all inter-area routes here. So when we did this here. And that's what we expected. essentially the Impetus VPN that's acting as our super backbone. Essentially, it's acting as an area zero, essentially tying these areas together. Even though they are both quote unquote area zero route, CE on the CE between 3 and 7 and the CE between 6 and 8, they are both running OSPF area 0. The super backbone ties them together, and they appear as inter-area routes. Now, if I go on to 6, specify the domain ID to something here. So now my domain ID will be different here. So now the domain ID will be different. And clear IP BGP star. I'll just clear the whole process so it jump starts everything. Clear the whole process too. Process 100. That one too there. Okay. When I did the clear all, I cleared them, but you can clear them for that particular process there. OSPF is the only protocol that doesn't get into that. It doesn't really get into the VRF type config like with EIGRP. You're going to clear EIGRP neighbors for that particular VRF. With OSPF, it's just a process. Okay. So here, now you see they're all external. See them? So all the routes here are external routes. And it's because the domain IDs do not match between 6 and 3. By default, the domain ID was inferred off of the process ID. But since our process IDs do not match now, the process IDs match, but I manually set the domain ID. Let me show it to you real quick here. Here, it's been set. So before, since they had the same process ID, the process ID is used to derive the domain ID. So since their domain IDs were the same, the routes showed up as inter-area. Since I change it on one side, they are going to now treat them as external routes. So that's why you saw on R8, the routes were now external. All right. If the process IDs were different, you would also run into the same problem. So if the process IDs were different, you would also run into this exact same issue here. And let's go. All right. Let's look at this here. Let's look at the route. Show IP route. Sorry, show IP, BGP, VPN, all 10.1.7.7. So we can see here what the domain ID is here. Tells you right there, the OSPF domain ID. Let me go on the other side and look at it. Show IP BGP VPNB for all 10.1.8.8. And you can see here, it is different than what it is up here. All right. So if you want the routes, I mean, you're using these techniques to manipulate how these routes are advertised, or how these routes are not advertised, but how they're being learned by other sites. Okay. So you can see this one right here. The domain IDs don't match. You can see this one is a domain ID of 100, 64, and hex is 100 in decimal there. And this one, of course, is what we manually configured there. I could go back on to 3 and give it the exact same domain ID, and then everything will work there. All right, you want to know these particular issues. You want to know what these issues are, why they're, not issues, but you want to know these different methods to affect how these routes are learned. Because especially when we start getting into using a backdoor link, when R7 and R8 has a backdoor link, you really want to maybe prefer that backdoor link or not prefer that backdoor link, so it's going to really get in there and affect us here. So let me go back real quick before we take a break here. Let me go back and take this off. Clear the process here. And what I'll do is I'll bring up that backdoor link between the two between R7 and R8, because this is going to come into play after we get back from break here. Okay, let's bring this up. Should form an OSPF neighbor relationship across us here. Starting to come up here. We don't have any routes yet learned across. Okay, now it's up. Look at a second. Once it comes up, it should switch over for the there it goes, it switched over. Yeah, it took a while. So now it's switched over to using the backdoor link. And the reason it's using the backdoor link, is because those routes are intra-area. The routes we learned across the MPLS VPN are inter-area. So in this case, essentially what we have is the MPLS VPN is being used as a backup. So the MPLS VPN is being used as a backup to the link between R7 and R8 there. So IP OSPF database. So here's routes originating from 3. There's routes originating from 6. Router ID there. Okay, so we are learning the routes. They're in our OSPF database. Learn the LSAs, I should say. They're in the OSPF database here, but we're not using the MPLS VPN. So what we're going to do now is we're going to take a break, but when we come back, we're going to configure the network so that the input of this VPN is the preferred path. Okay, and it'll be the preferred path. As you can see, what the issue is, we need to make those routes across the input of this VPN intra-area routes. Okay, as long as they're inter-area routes and they're identical with the same network and the same mask, we're not going to prefer the input of this VPN over that link between the two there. Okay, so let's take a break and let's come back. Let's take a break and let's come back at 5 till 10, and then we'll continue on with the OSPF sham link. It's what we're going to use to solve this here. So let's go ahead and take a break, and we'll start back then. All right, let's go ahead and continue on here. What we've gone over so far with OSPF, let's look at these two examples. We've gone over where the PE to CE routing, we're using the same process ID. So we're using the same process ID. That means that the domain ID will be the same between 3 and 6, which infers that essentially your backbone, this becomes essentially a big area 0. This is your super backbone here. So this is essentially your OSPF area 0 here. The routes learned from this area 0 go to this area 0 and go out to this area 0 here as inter-area routes. So as inter-area routes, because the process IDs were the same and the domain IDs were the same. Now, when we change the domain ID, so when we change the domain ID on our 6, it essentially said that this is not one big super backbone anymore. So this is not one big area 0 here. So what happens is the routes essentially, it's like getting passed from one OSPF process to another OSPF process. So essentially, routes going across the input of this VPN will show up as external. So the first option we saw was they were inter-area. The other option was they were external. Now what we're going to see is we're going to make them intra-area. And when I mean intra-area, the routes that are originally intra-area, they're going to remain intra-area. The routes that are external will always remain external no matter what. The routes that are inter-area will always remain inter-area unless the domain IDs don't match. Then they get bumped up to external. So you can make it from intra-area to inter-area and inter-area to external, but you can't go backwards. You can't say, I'll make an external inter-area, or I'll make an inter-area intra-area. It's only backwards in the path of the preferred route selection for OSPF. So you can take intra-area routes and make them inter-area, depending on how you have that backbone configured. You could make them external. You could leave them as intra-area routes. All right. So let's look at the issue real quick on the router. Let me share this out. Share out my screen real quick here. And okay. Now we have this. We also have this backdoor link in place here. What I'm going to do is